Hello class. In this video lesson we are going to be talking about probability. Specifically, we are going to examine the addition rule and the formula for conditional probability. A couple of the questions from your problem set are eliciting this knowledge, and I just wanted to show you why and how to calculate this information. So in problem 2.1f, it's asking for the probability that a tire selected at random is either a high performance or fails to last 40,000 miles. The big thing with that question is that word or. That is telling you that you have two independent events here. They are not joined. So your brain is supposed to clue on the fact that this may be where you would employ the addition rule. Now, the addition rule is just a very simple formula. And it simply is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now, A is typically referring to the left side of your contingency table, and B is referring to the information on the top. Now, your contingency table is also known as your sample space. And whatever you have designated as A and B, the complement, as it is referred to in the textbook, would be denoted by this B apostrophe or A apostrophe. So in our example, A is either the tire does or does not exceed 40,000 miles, and B equals the type of tire. And then A and B would be the combination of both. So to employ the addition rule, it's simply a matter of finding this information in your sample space or contingency table and just plugging those values into the formula. So I have things color-coded here so you can quickly see where you can find this information. So the question was asking, what is the probability that a tire is high performance and does not exceed 40,000 miles or fails to last 40,000 miles? Well, A, if you recall, is referring to whether or not it does or does not exceed 40,000 miles. We're interested in if it's not exceeding 40,000 miles. So we're going to go all the way over to the right side of the table. We're interested in this 7%. So we would just plug that number in here in our formula. We're also interested in whether or not the tire is high performance. That's the 31% at the bottom of the table right here. And then we're also interested in whether the probability of A and B, because we need to subtract this. And that's simply a crosswalk between high performance and does not exceed, and that gives us 3%. So if you just plug in the values of the formula, 7% plus 31% minus 3% gives you 35%. Pretty simple. Now H and I, these are joined events. You'll notice there is no or in there. There could be the word and, but the way the question is written, it's not necessary grammatically. But you need to cue in on the fact that these are two joined events, so this is when you would employ the conditional probability formula. So this first question is asking what's the probability that an all-weather tire selected at random exceeds 40,000 miles of tread life. So a conditional probability is what is the probability of A given B, and that's what this vertical line means, equals the probability of A and B divided by your given, which is B. And again, I have these color-coded. So the probability of A and B is simply all weather and exceeds 40,000. That's our 65% here. So we would just plug that number into our formula. And then the probability of B is 69%, because all we're interested in is whether or not it's an all-weather tire. So you just simply do the math. 65% divided by 69% equals 94.2%. that's the addition rule and the formula for conditional probability. It's simply a matter of specifying your A's and B's into these formulas and doing the math. That's it. Any questions, just ask.